Welcome back. In our previous videos, we have learned the basics of linear equation, and we have covered activity 10 and the embedded assessment that follows. In this video, we'll be doing activity 11, and activity 11 is all about slope. So let's recap what we have learned about slope. The first way we calculate a slope is by rise over run, and we have done that in the previous video, rise over run. We covered how to find slope using rise over run in our previous video. And the second way that we can find slope between 2 points in a line is by changing y over changing x. We also covered that in our previous video. The third way we can find slope is by vertical change or horizontal change. And we will cover that in the later point of activity 13. You just need to know this vocabulary right now. So, let's start with activity 13. So, activity 13, there's the scenario that's given to us, and it says Misty Flip worked odd jobs all summer long and saved her money to buy passes to a ski lift at the High Ratio Mountain Ski Resort. In August, Misty researched lift tickets, prices, and found several options. Since she worked so hard to earn this money, Misty carefully investigated each of her options. So this is her options that she found. So let's read number 1. Let's see what it says. Suppose Misty purchased a daily lift ticket each time she goes skiing. Complete the table below to determine the total cost for lift tickets. So we have to right now focus on this one. So for 0 days, since she's never gonna go there, she has to pay $0. So if she goes there 1 day, since it's daily, she has to pay 30. So it's gonna increase by 30 each day. So you just add 30 to the previous day, and that's how you can complete this table. And let's read the second problem now. Let's move on to the second problem. The second problem says, according to the table, what is the relationship between the cost of the lift tickets and the number of days? So we can see that for every number of days, the cost of the lift ticket multiplies by 30 to the number of days. So basically, we can model that situation by 30x, and x will be our number of days. So since we are finished with the first page of activity 13, that's page 133, activity 13, lesson 11-1. Let's move on to page 134, lesson 1-1, and activity 11. So let's move on to number 3. So number 3 says, let D represent the number of days for which Misty bought lift tickets, and C represents Misty's total cost. Write an equation that can be used to determine the total cost of lift ticket and Misty skis for D days. So this is just like the previous model we did. Over here, we just used on the previous page on 133, we just used X. So instead of that, all we have to use change a variable to D. So it'll be 30D equals C, and C will be a total cost. So let's move on to number 4 now. Number 4 says, plot the data from the table on the graph below. The data appears to be linear. What do you think this means? So first you plot the data, and it's linear, and it appears to be linear because the rate of change is constant, and you know that because linear lines have the same slope, and then the same slope, then the rate of change would be constant too, and it all increases by 30, as you can see. So let's move on to number 5. So you have to label the leftmost point on the graph. The left is this side, so you label this A, and then the next 3 points B, C, D, E, and F, and G. So you can do that, and then you can continue your line. And then number 6 says, according to the graph, what happens to the total cost of the lift tickets as the number of days increases? Justify your answer. It increases by 30. For example, for 1 day, it was 30, and for the second day, it was 60. You can see that point B is 30 and point C is 60. So let's move on to 7. Number 7 says, describe the movement on the graph from one point to another. So, as you know, vertical is going up and horizontal is going this way. You can remember that by the horizon is this way and the vertical is up. So, for A to B, so the vertical would be 30 and the horizontal would be 1 because it's 0 to 1. And same with the rest of them. So we could see this all is 30 and all the horizontal changes is also 1. So let's move on to page 135, activity 11, and we're still on lesson 1-1. So we're on 8A right now. It says the movements you trace in item 7 can be written as ratios. Write ratios in form of vertical change or horizontal change. This is the thing we talked about. You can find slope by this. So we're going to find the slope of the line by doing vertical change or horizontal change. So A to B. So we had to go back to the previous page and we could see A to B is 30 over 1. So we write that over here, 30 over 1, and we do the same for all these points. So let's move on to 8B. So 8B says vertical change can also be described as a change in Y. Similarly, horizontal change can be referred to as change in X. So therefore, the ratio of vertical change over horizontal change can also be written as change in Y, change in X. So we already covered this in previous videos, and since these are the same, so they will provide us the slope of the two of the line. Determine the change in Y and change in X from A to C in item 4. Write the ratio as change in Y or change in X. So we can see that A to C, let's move on to a graph. A to C is, if we go up, the vertical change would be 60 and the horizontal change would be 2. So, right? So that's what, right? 60 over 2. This is our ratio. So now let's move on to C, D, E, and F. So it says, continue to use the data from item 4. Determine the change in Y and change in X for each movement described below. Then write the answer as a ratio, change in Y or change in X. So from B to E, let's see this. So if you go back to the previous page, you see it's increasing at 30, 60, 90. So you had 90 for change in Y and 3 for change in X because you could see 1, 2, 3, and then you could see that. And then you could do the same for all these other ones, D, E, and F. So let's move on to the next page, and that page is 136, lesson 1-1, activity 11. So we're on number 9 now. So number 9 says, describe the similarities and differences in the ratios within item 8. How are the ratios related? So let's go back to the previous page. So these are all the ratios here. So some similarities is these all simplify to 30 over 1 or 30. So that could be the similarity, and as you see, I've written the similarity. All the ratios simplify to 30 over 1, but the difference is that some ratios have negative points in change in Y or change in X. We could see that by over here, E to B, the change in Y and change in X are both negative. So that's the only difference that you can find over here. So let's move on to number 10. And number 10 says, what are the units of the ratios created in item 8? Explain how the ratios and units relate to Misty's situation. The units are 30 units because we haven't have any units here, so we just have to put the units as units. So the units relate to Misty's situation because for every day increased, her cost increased by 30 because the daily lift ticket costs $30 per day. And let's move on to number 11 now. Number 11 says, how do the ratios relate to the equation you wrote in item 3? Because they relate because they both represent the slope and the constant rate of change of 3. So the constant slope or the constant rate of change is 30, so that's what they represent. So, since we have learned about change in Y and change in X, I want you guys to do number 12 on your own and see how much you can know. And we already know about similar triangles from last year, so you can apply that knowledge in changing Y or changing X, and you can solve number 12. So let's move on to the next page, which is page 137, activity 11, and lesson 1-1. So let's read this because this might help us in the next problem. So it says, The slope of a line is determined by the ratio change in y over change in x between any 2 points that lie on a line. The slope is the constant rate of change of a line. So we should probably circle because this is a good vocabulary we should know. It also sometimes is called average rate of change. We should probably circle this too because it's good vocabulary. All linear relationships have constant rate of change. So this is really important. So maybe you should refer back to this when you're solving problems. The slope of a line is what determines how steep or flat the line is. And this will help you in the activity practice, this point. So lastly, it says the y-intercept of a line is the point at which the line crosses the y-axis, 0, y. So you already know the y-intercept and how to calculate it. So number 13 says draw a line through the points you graphed in item 4. Use the graph to determine the slope and the y-intercept of the line. How do the slope and the y-intercept of this line relate to the equation you wrote in item 3? So first you have to draw a line through item 4 right here, which we already did. And item 4, just in case you forgot, is on page 134. So first you draw a line, and then it says determine the slope. We already know the slope is 30 over 1 or 30, and the y-intercept is 0, 0. You can see that by over here where it crosses the y-axis, it's at 0, so this is our y-intercept, so it's 0, 0. And they relate. So then the next problem is how do they relate to item 3? So if you want to go back to item 3, let's do that. And item 3, this is our equation, so keep this in mind and let's go. So in item 3, let's write our equation right here. So this is our equation, right? So they relate because slope and this slope is similar. Plus, since if we have y-intercept 0, we don't do plus 0, but there's always a plus 0 if there's no if the y-intercept is 0. And since the y-intercept is 0, 0, so is the y-intercept of this equation. So they relate because the slope and the y-intercept of both are the same. So you can see that by this right now. And let's do number 14 now. Complete a table to show data points you got in item 4. Use the table to indicate the ratio of change in y or change in x, and to determine the slope of the line. So we can do that by just going back and seeing, oh, 130, and then you can just write 130, 0, 0. You can fill this out on your own. We already know the change in y is 30 because we figured that out over here in the vertical change. And the change in x is 1. We already figured that out on the horizontal change. And then you can just combine this and you can find the slope. So we already covered that. So let's go to the next page, which is page 138, lesson 1-1 and activity 11. So this is a check your understanding. And let's do number 15. So, number 15 says, find the slope and the y-intercept of each of the following. Remember to use the ratio change in y or change in x. So we can find out the y-intercept of this by where it crosses the y-axis. And it crosses the y-axis at 0, 0, if you could see. So that's our y-intercept. And the slope of the line is 3 because you take 2 points, 0, 0, and let's take 1 and 3. So 1 and 3, subtract 0, 0 gives us 3 over 1, and that equals to 3. So that's how you solve B2. Use the same steps as you did for 15A. And let's do 15C now. So 15C, you can find out the y-intercept because the y, since it's 0, 0, if we plot it, it would cross the y-axis at 0, 0, so that would be our y-intercept. And our slope would be 2.5 because if you take these 2 points, then you subtract 2.5 by 0 and 1 by 0, you get 2.5 over 1, and that equivalents to 2.5. Use the same steps you did in item 15C to solve item 15D. So let's go to 15E. 15E says, look back at the figure for item 12. With a point P that's 9 units up from point W and 15 units to the right on the line that contains point WVZ, use similar triangles to explain your answer. So, as you know, So as you know, let's go back to item 12. So it's talking about this right here, and if you forgot, item 12 is on page 136. So it's saying that if there's a point over here, that's 9 units, this is 9 units, then would this area be 15 or no? So we can calculate that by using similar triangle. So let's use a similar triangle. It's 1, 1, 2, 2, and 3, 3. Okay, so let's use the ratio. We have to find 1, 3, right? So let's use the ratio 1 over 3. And since we know that this is 3, we need to know if this is 9 or not. So if this is 9, then this is going to be 15. So let's do this. So this is equivalent to each other, as you can see. So we can know that this will also be equivalent. So let's go back. Let's go to number 16. Number 16 says, John is longboarding at a constant rate down the road. If 2 minutes after he leaves his house, he's 1,000 feet away, and at 5 minutes, he's 2,500 feet away from his house, what would be his average rate of change? So you can calculate that by, since you know that if at 0 minutes, he will be 0 feet away from his house, because he starts at his house. So you can just go, you can just do change in y, change in x, 2,500, or you could take these 2 points. I'm going to take these 2 points because I don't know the y-intercept of this. So you could just take this, subtract it by 1,000, and then you can do that for the bottom 2, and then you will get 1,500 and divided by 3, so that gives you the answer of 500 feet. So the average rate of change is 500 feet per minute. So let's move on to the next page, which is page 139, activity 11, lesson 1-1. So since this is lesson 1-1 practice, and we already did the rest of the lesson together, I want you guys to do 17, 18, 19, 20, 21, 22, 23, 24 on your own, because this and this is just like Misty's situation. So we already covered one real world problem. So since this is going to be very similar to Misty's situation of the ski lift, you can solve this on your own because you already had one practice. So let's move on to the next page, which is page 140, activity 11, and lesson 11-2. Okay, so now let's move on to number 1. So before we do number 1, let's read this little scenario right here. Remember, Misty had saved her money to buy passes to a ski lift at the High Ratio Mountain Ski Resort, and we should also remember this table because this will be important for the Misty situation. So let's read number 1. Number 1 says, suppose Misty purchased a 10-day ticket package that costs $80 plus $20 per day. So we already did this in lesson 1-1. So now we're doing this one. Okay, so complete the table below to determine the total cost of the lift tickets in 10-day package for 0 through 6 days. Be sure to include the initial cost of $80. So if you go 0 days, you still have to pay the $80 upon purchase. So that'll be over here. And if you go 1 day, then you only have to pay $20. So you add 20 to 80, and then you get 100, and you do so on for 2, 3, 4, 5, and 6. And that's how you get that's how you finish the table. So let's move on to 1B. 1B says, explain how you know the data in the table are linear. You can know the data in the table is linear because there's a slope of 20 per day, and also because data has a constant of proportionality of 20. So you can see it's increasing by 20 each time. And so let's move on to the next page, which is page 141, activity 11, lesson 11-2. So let's go number 2. Number 2 says, plot the data from the table given at the given axis, and draw a line through the point you plotted. So let's plot all the points. You can plot all the points from the table on the previous page, and then you can draw a line through them through a ruler or whatever you prefer. And you should probably draw a continuous one because it doesn't end at 6 days. You could even do one for 10 days, so you should draw a continuous line. And let's move on to number 3. Number 3 says determine the slope and the y-intercept of the line graphed in item 2. So, and explain how these values relate to Misty's situation. So we could see the slope is 20 because it's increasing by 20. Plus the y-intercept is 80 because it crosses the line y-axis at 80. So the y-intercept is actually 0, 80 because we have to put the point and not just 80. And the slope relates to Misty's situation because the price per day to go skiing is $20, and the y-intercept relates to Misty's situation because the initial fee for purchasing that package is $80. So let's move on to number 4. Number 4 says, let D represent the number of days Misty plans to ski and let K represent Misty's total cost. Write an equation that could be used to determine Misty's total cost if she bought a 10-day package. So first, the slope, and then we put D with it because every day which increases, she has to pay $21, plus the initial fee is 80, so this will be our equation. So let's move on to number 5. Number 5 says, compare and contrast the lines associated with the data for daily lift tickets in item 4 in lesson 11-1 and the data for 10-day package in item 2. Include the similarities and differences in their equations. So first, we have to know that first we have to compare the two equations, right? So as you know, our previous equation is 30D equals C. And our NAS equation is 20D plus 80 equals K. So first, in the previous lesson 1-1, we could see the y-intercept of this is 0, 0, but over here is 0, 80. So that would be one of our differences, and our similarities would be both the graphs are linear, and that's because they have a slope, a constant slope. And another difference would be that the slope of the previous lesson's equation is 30, while item 2's is actually 20. So that would be another difference. So let's move on to the next page. And that is page 142, lesson 11-2, activity 11. So let's just check your understanding first. So let's go to question 6. Question 6 is Veronica and Caitlin work in the ski shop at High Ration Mountain. Because Veronica works on call and doesn't have a set schedule, she earns $10 plus $6 for each hour she calls in to work. Caitlin's earnings are modeled by the graph shown. So this is Caitlin's earning, and this is Veronica's earning. So write an equation to represent the girl's earning. So as you can see, for 1 hour, it's $7, and for 2 hours, it's $14. So that would be Caitlin's earning, and for Veronica, it's $10. That's her y-intercept, and $6 for every hour, so 6H. So her equation would be 10 plus 6H equals C. So state and interpret the slope and y-intercept of each girl's equation you wrote in part A. We had a lot of experience with slope and y-intercept, so I want you guys to do 6B on your own by just looking at this equation above. So let's move on to 7. So 7 says a line with a slope of -half contains the points 2, 3. Use the my notes section to graph the point and use the slope to give the coordinates of the other points on the graph. So first, in the my notes section, you can create a graph. And then you could first plot 2, 3, which is mine is right here, and then you draw a line with the slope of this. And then you can see, so I chose 3 points are 4 and 2, 6 and 1, and 8 and 0. You could choose any points from this line over here. Or you could extend the line anywhere else, but I just chose to do this segment. And let's go to number 8. Number 8 says, although $390 seems a little expensive, Misty considered the unlimited seasonal pass. So let's move on to the previous page. And so now we are at this thing right here, and there's a fixed rate of $390, and it's not going to change no matter how many days she goes or if she doesn't go at all. So first, she compared a seasonal pass to a daily lift ticket at $30 each. How many times would Misty have to go skiing before she would save enough money with $30 seasonal pass? So as you guys know, 30 times 13 is $390. So she would have to go more than 13 times to save with the unlimited pass. So that's what item A wants you to know. So item A just wants you to compare the seasonal pass to the daily lift ticket. And so let's go to item 8B. 8B says complete a table below for the total cost of the unlimited season pass for 0 to 6 days. So it's gonna be $390 no matter what, because every day there's a fixed price and you already paid it on before you went. So it's going to be $390 for all days. So let's move on to 8C. 8C says explain how you know data on table is linear. It's linear because the slope's the same, and you can know the slope's the same because there's a slope of 0 for each day because she pays nothing. And let's move on to 8D. 8D says what's the rate of change of the cost of tickets with the unlimited season pass? It's $0 as we discussed in the previous question. So let's move on to the next page, which is page 143, activity 11, lesson 11-2. So let's move on to number 9. Number 9 says, next, Misty compared the price of the unlimited season pass 10-day packages that she would use for 20 days of skiing. Which package would be the best buy? Why? Justify your answer. So first, let's calculate the unlimited pass. So the unlimited would be $390, and so let's go back to the second page, page 140. So the 10-day package would be $80 plus 10 days for purchase. So if you go for 10 days skiing, that would give her 200 plus 80, and that would equal 280. So we have to times that by 2 because she wants to go skiing for 20 days. So if we times that by 2, we come up with 560. So remember this number, and let's go here. So for the 10-day package, we had to pay $560. So now we know that this is going to be more cheaper than the 10-day package. So the package would be the unlimited package, because for 10 days pass she would have to pay more, and that would be 560, and 560 is more than 390, which is the cost for unlimited pass. So that's why she should go here, and I justified my answer by saying that by looking at the table information provided below. So I justified my answer like this. You don't have to explain your justification, you just have to show your work for justification. So let's move on to item 10. Item 10 says, if Misty skis the following number of days, which of the 3 packages should she purchase? Explain your reasoning for each. So for 6, she should purchase a daily package because the 10-day would be a race. So I mean that by 30 times 6 is 180, while if we did a 10-day package, it's gonna be 80 plus 120, and that's gonna be 200. And since 200 is more than 180, we are gonna cancel this off, and we obviously know that 390 is more than 180, so we're gonna cancel the unlimited off. So that will give her the daily one, so she should go for the daily pass. For 8 days, the daily and the 10-day package cost the same, but I would prefer a 10-day package more because she can go more days and she would have to pay less than the daily one. But if she's only going to go for 8 days, daily and 10-day package would cost the same, and that would be because the daily package would cost $240, and the 10-day package would also cost $240 because 80 plus 160 is 240. So they cost the same. She could choose any one of these two. And for item 10C, daily or unlimited, because they both will cost us the same. That will be because 390 is the unlimited, so we can leave that aside. And the 13 times 30 is also 390. So that would cost the same, but I would prefer unlimited because she can go for a more number of days. But if she only wants to go for 13, she can choose any one of these two. And for 16, obviously we know that daily is going to cost more, so she should pick unlimited because, as you can see, and the 10-day package won't also work because it'll be 560. It will be around like more than 390. So she should pick the unlimited one. So item 11. Let's move on to item 11. Item 11 says, write a persuasive letter to Misty based on the analysis and make a recommendation for which package she should purchase. Include multiple representations, graphs, tables, and or equations to support your reasoning. Provide a concluding statement that summarizes your reasoning. Well, you could do this on your own because we already did our analysis here and on the previous problems that we did. So you could write a persuasive letter on your own, and this is going to be really easy. And the graphs you could include would be, let's move on to the previous pages. Item 2 graph on page 141, plus you could include the item 4 graph on 134. You could do that, or you could include the equations for each one of them. And item 11. So let's just check your understanding for lesson 11-2. So let's do number 12. And before that, let's read the scenario. The scenario says, Emily rides her bike 24 miles in 2 hours. So item 12 wants you to create a ratio of Emily's miles per hour. So we can know that by, since 24 for 2 days, do 24 and colon 2 or 12 colon 1 if you want to simplify. And for let's move on to item 13. Item 13 says, use the ratio you created to determine how far Emily can ride in 5 hours. So since we know that the ratio is 12 over 1, so if she has to ride in 5 hours, we put the 5 in the denominator and we do x. And then we do cross multiply, so x equals 60, and we can get that, and then you can get 60 miles. And I also did my work over here. If you can't see this, you can look over here. So let's move on to item 14. Item 14 says, if Emily rode her bike for 42 miles at the rate you determined, how long does she ride? So let's go here. So you can do, so you know that she will ride her bike for, okay, so she'll ride her bike for 3.5 miles, and we know that she rides for 12 miles, so 12 over 1 equals 42 over x, and then you could cross multiply like this, and then you can also divide, and then that will give you 42 over 12, and that will equal x equals 3.5. So she rides for 3.5 hours. And then let's move on to 15. 15 says, Rain rides her bike. Mom! How could you do? Let's move on to item 14. Item 14 says, if Emily rode her bike for 42 miles at the rate you determined, how long did she ride for? So we can do fractions. So we can know that 12 over 1 will equal 42 over x, because this is miles and this is hours. So we have to figure out the hours, and we already know the miles. So then now we can cross multiply 42 by 1 and 12 by x. So that will give us 42 equals 12x. And then we can divide by 12 because we learned inverse operations, and that will give us x equals 3.5. So then we can plug in 3.5 here, and we can say 3.5 hours. And if you're going to cross-check any of the problems I'm doing right now, you can do that by plugging in the number in the variable in the equation. So let's move on to item 15. Item 15 says, Rain rides her bike 37 miles in 3 hours. If Rain started the same time as Emily and rode her bike at a constant rate for 42 miles, who finished first? Explain your reasoning. So we know that Rain will finish first because her constant rate of change is more. And we know that because 37 divided by 3 is 1, 2 points dot dot dot. It's something like that. And 42 divided by 24 divided by 2 would be 12 and done. So since her constant rate of change is more because it goes into decimal, we know that Rain will finish first. So let's move on to the next page, which is page 144, lesson 11-2, activity 11. So let's read the scenario over here for lesson 11-2 practice. We'll do this 11-2 practice together. So it says Lucas conducted an experiment on rate of water evaporation. He placed 50 ml of water in a measuring cup at room temperature and collected data on the amount of water in the cup every day for a week. His results are shown in the data table below. So for 0 days, it's 500 and so on. So we know that this is our y-intercept right here. And so we need to figure out the rate of change. So let's read item 16. Item 16 says, where's the rate of change in the amount of water in cups? So we can figure that out because it decreases by negative 25 ml. So that would be a rate of change negative 25 ml or negative 25. And let's move on to item 17. Item 17 says, on a graph, these data would what would be the y-intercept? Well, we figure out the y-intercept would be 0, 500. And what does it represent in Lucas' experiment? We know that in Lucas's experiment, it represents how much water he put in the measuring cup because that's what he said in his scenario. So that's the answer to item 17. So let's move on to question 18. Question 18 says, write an equation that can be used to determine the water level L after days. So L is our other side of the equation, and D is on the other side. So since we know that this is our y-intercept, we have to do 500 subtract, and since we know that this is our slope, 25, negative 25, so that's where you subtract 25 and then put D over here because that's the number of days that she gets it subtracted. So that this is our equation. And then let's move on to question 19. Question 19 says, at this same rate of evaporation, how many days will it take for all of the water to evaporate? And then you can plug in any number you think might be close enough, and then that time you figure out it's 20. Or you could put 0 in place of L, and then you could solve the equation algebraically by subtracting 500 from both sides, then multiplying, then dividing by negative 25 from both sides, and that'll give you 20. Or you can plug in any number you want. So there are two ways, but I prefer you put in 0 for L because that'll be shorter. So let's move on to the next one. So let's read this. Lucas wants to see how lowering the temperature of water would change the result of his experiment. He placed a 500 ml again of water in a measuring cup. So this y-intercept will be the same. But place the cup in the refrigerator and collected data as before for a week. His results are shown in the data table below. So there's a change because the measure for water measure is 325 and the water measure over here is 430. So we know that there's a change over here. So let's continue on reading. Let's do 20. 20 says, where's the rate of change in amount of water per cup? So we see that this is going down by tenths each time. So our rate of change is negative 10. And let's move on to question 21. Question 21 says, write an equation that can be used to determine the water level L after days. So we know that L goes here, D goes on the right side, and it's 500 because this is our y-intercept. Subtract 10 because negative 10 is our slope. So L equals 500 subtract 10D. So this will be our equation. So let's move on to 22. 22 says, at this rate of evaporation, how many more days will it take for all the water to evaporate in a refrigerator. Experiment that in the room temperature experiment. So there, like I said in the previous question 19, yeah, there are two ways to do it. So the first way is to plug in 0 over here and solve the equation algebraically, or the second way is to, since 20 days it will take for this one, so you know that 22 will be more than 20, so you can plug in any number you feel like on D and C. But I prefer doing the plugging in 0 over here, substituting in 0 and figuring out, but you could do it any way you like. So let's move on to page 145, activity 11, and we're on activity 11 practice. And the name of the activity 11 practice is exploring slope. Since you already did that. So we're still in a mystery situation now because this is high ratio mountain. So let's move on. Let's go do the question. So let's do lesson 1-1's practice right now. So let's go to number 1. Number 1 says Misty determined that she gets 64 miles per 2-gallon gas from her car she drives from her house to a ski slope. So now instead of the ski, it's the gallon. So first we should underline this because this is important, and yeah, for the question. So what's the ratio? So we know that the ratio is 62 miles colon 2 gallons, and then we could simplify this to 32 miles and 1 gallon. So let's move on to 1B. 1B says, using the ratio found in part A, determine how far Misty can go on 1 gallon of gas. We know that she can go 32 miles because this is our ratio right here. So let's move on to 1C. 1C says, how many miles could Misty travel on a full tank of 12 gallons of gas? So we know that our rate of change is going to be 32. So 32 times 12, and then you can figure it out. It's 384 miles. So let's move on to 2A. So let's read the scenario for 2. Scenario says Brienne rides her bike 84 miles in 4 hours. So 2A, which you create a ratio of Brienne's miles per hour. So we know that because our initial ratio is going to be 84 miles for 4 hours. So if you simplify that, you come up with 24 miles for 1 hour. And let's move on to 2B. 2B says, using the ratio found in part A, determine how far Brienne can ride in 7 hours. So since we know that she will ride 21 miles in 1 hour, so you times 21 by 7, you get 147 miles. So let's go to 2C. 2C says if Brienne rides 57 miles at the rate indicated, how long will she ride? Justify your response. She'll ride for approximately 2.7 hours because, let's create an equation for this. So our equation would be y equals 21x. So you plug in 57 for y, and then you can solve this algebraically by dividing 21 on both sides, and then x will be close to 2.7 hours. So let's move on to number 3. Number 3 says, where's the slope of the line shown? So we can calculate the slope by choosing 2 points on the graph and then do the change in y over change in x. So I want you guys to solve this on your own and see what answer you get. So let's move on to 4. 4 says, find the slope and the y-intercept of the line represented by each of the following. So first, let's do 4A, and then we'll do 4B, and then I want you guys to do C and D on your own, since you'll have practice with 2 of the problems like this. So first, we know the y-intercept of this 4A will be 0, 1, because it's right here, and you can figure out the slope by doing change in y, change x. So 7 subtract 1 is going to be 6. 3 subtract 0 is going to be 3. So 6 over 3 is 2. So this is our slope. And let's move on to 4b. 4b is, our y-intercept is going to be 0, 4 because it's shown right here. And we know we can figure out our slope by choosing 4 points and doing it. So 4 4 plus 4, because since 4 subtraction 2 negatives equal a positive, so 4 plus 4 divided by 0 subtract 4 gives us 8 over negative 4, which decreases to negative 2. So 8 over negative 4 decreases to negative 2. So since you did these practice problems with me, you guys can do 4C and 4D on your own. And let's move on to 5. So 5A, so let's read the scenario first. Find the slope and y-intercept for each of the following graphs. So 5A, we can know our y-intercept because this crosses the y-axis right here. So 0 and 3. So 0, 3 is our y-intercept. And then let's see our slope. So let's take 2 and 1 and 1 and 2. So we know that our y-intercept, our slope for this is going to be 1 because the changing y or changing x, or horizontal or vertical changes 1 for each. So 1 over 1 equals 1. So let's move on to 5b. 5b, we can find out our y-intercept because it's right here, 0, 5. And we know our slope is going to be 4 because, so since this is 5, 1 is 1. So we, our horizontal change is 1, so that's on the bottom, and our vertical change is 4, so that's on the top. So, and then since we're going downwards, it's going to be negative, right? So, which gives us negative 4, so that's our slope. So let's move on from page 143 to page 146, activity 11, and we're still on activity practice. So I want you guys to do C and D on your own because we already had practice with 5A and 5B. So let's move on to number 6. Number 6 says, if a line has a slope of negative half and contains a point 2 and 3, then it must also contain which of the following points. So since we know that decreasing by half, let's see. We know that this won't work because since this is since we can know that this won't work. So we know that because let's create an equation for this. So we know our slope, which is y equals negative half x. And then, but we don't know our y-intercept yet. So we could plug in the values over here. That'll be 3 equals negative 0.5 x plus b. I mean negative 0.5 and 2 times 2 plus b. So we need to find what b is. So first let's calculate this. So this is going to be negative 1 plus b plus 1 plus 1. So we know that b is 4. So let's create our equation. Y equals negative 0.5 x plus 4. Then you can plug in these values and see if they work. And when you come on over here to D, you know that D will work because if you plug in 4 here, that'll give you negative 2, and negative 2 plus 4 is 2. So you know that 6D will work. So let's move on to 7. Number 7 says, if a line with slope of 3/4 contains a point with coordinates negative 1, 4, give the course of the 3 other points that must also be on the line. So since you had practice with 6, then you can create a equation like this and then complete number 7 on your own, since you already had practice with the previous question. So let's move on to number 8. Number 8 says, complete the following table so the data is linear. So let's figure out what the slope is and we can figure out this number. So we know the slope of this is 2. This is also 2. So 5 plus 2 has to be 7. So that's how we get 7 over here. And let's move on to 8b. 8b, we know the slope over here is 6. Slope over here is also 6. So 22 plus 6 is 28. So that's how we get 28. So let's move on to 9. Number 9 says, which of the following situations when graph would create a linear graph? Explain your reasoning. So first, let's start with C, and it will lead up to why 8 works. So we know the weighted sandbag as shuffle dirts are added would not be a linear graph because sometimes there would be less shuffle added and sometimes there'll be more dirt added. So it'll just depend, and some dirt weighs like more than other dirt, so you never know because there might be rocks in it, there might be something else. So this can't work. And let's add this. the speed of each car passing through an intersection. So this one worked because some drivers drive very fast and some drivers drive slow and some drivers drive medium. So this also won't work. And let's see number 8. So A says the height of wedding cake has 5-inch layers added. So it specifically says that 5-inch, so it's not going to be more or less. So it's getting 5-inch added to each. So this has to work. So for 9, the answer is going to be A, and I just explained you my reason. So let's move on to 10. 10 says, how does the value of the slope of a line affect the steepness? So as you know that the higher the value of the slope, the steeper the line is. So you can know that by, let's use this graph right here. So this is not very steep, right? Because since it says, okay, the steeper the lines, and the steeper the line, we can know that because this is not very steep. Steep means it will be vertical and not horizontal. So since steep, and then we can see this is pretty steep because it's 4. The value is 4, and for this, the value is negative. For this, it's half, and we know that since we have to calculate the distance of 4 from 0. Wait, stop going up. What do you? Let's move on to number 10. Number 10 says, does the value slope of a line affect the steepness of the line? So we know that higher the value of the constant difference, the steeper the slope. And that is because you know that the slope of -2 or 2 will be greater than the slope of -half or half. And we can see that over here because this is more steeper than this slope. So the slope of this is half and the slope of this is -2. So you can see this as this. So that's why we know that the higher the value of the constant difference, since the constant difference over here is 2, -2, and over here is 1. So this will be more steeper than this one. So thank you for watching this video, and on the next video we'll be covering activity 12 for the SpringBoard Course 3.